So this is a video that will just run through the equations for chapter 1, which is vectors. And these are the equations you should be writing in your formula sheet in your notebook. You'll be needing them when you do your next assignment on mastering physics. Now, as far as the guts of actually doing the calculations, there are videos in mastering physics that will run you through that. Okay, so if you want to look at the equation sheet that I'm looking at, it is in D2L under key equations. Okay, so the first equation looks like this: ax plus bx, and for y is ay plus by. Okay, so these are equations that you need when you're adding vectors. The components of the vectors are ax and bx. So the R stands for resultant, and that's the sum. And you'll be shown how you get the sum of vectors on mastering physics. Ax and bx, these are the components of the two vectors that you are adding. Now remember, these components, they're just numbers. Okay, they don't have directions, they're just numbers, either positive, negative, or zero. Okay, and the way that you write a vector is in terms of its components. So axi hat and ayj hat. And if you want to go to 3 dimensions, you've got the az as well. Now, I don't know why that equation doesn't have a z in here. You would have an rz as well, which would be az plus bz. So that was missing in that equation sheet. Now, notice how the components are just numbers. The directions are the unit vectors. So the I hat vector points either in the x direction or the negative x direction. J hat points in the y direction, k hat in the z direction. Okay, so that gives you the actual directions. So that's how you denote. So these guys are the unit vectors. And it doesn't matter where those vectors are. So if you have your x, y, and z, and you have an I hat here, you could have an I hat up here as well. So wherever you happen to draw your vector, like if they were up here, the I hat doesn't have to be down here on the coordinate axis. It can be anywhere in space. It always points to the right if x, we define x as being to the right. Okay, and then I talked about the physical meaning of the dot, scalar, and vector products. But here's the actual equation that you're going to need in your equation sheet. So A dot B is magnitude of A, magnitude of B, cosine of phi. And remember, you can just write the A without the vector sign, that means the magnitude of the vector, or you can be really fancy about it and actually write the full notation, which is the parallel lines around the vector telling you that that's magnitude. Okay, so whether you just leave the vector sign off or you write those parallel lines means the same thing. And that's the length of the vector. And remember, these are just numbers. So this is magnitude of vector, and it has whatever units the vector has. So if it's a displacement vector, it's meters. If it's velocity, it's meters per second. If it's force, it's newtons. And so these are just generic vectors for now. So this means magnitude. Now this phi is very important. This is the angle between A and B. And when you find that angle, it's always the smallest angle between them. So first of all, you have to put the vectors, not tip to tail, but tip to tip, or tail to tail, I guess. So there's A, there's B, that would be phi. Okay, if A were like this and B were like that, then this is phi. Okay, so you always go the shortest distance between A and B to get the angle phi. And notice how the cosine could be positive, it could be negative. And so now this dot product, so this is the dot product, or scalar product. And this is just a number. It's not a vector. So it's a positive number, negative number, or 0. Okay, so if you happen to know the magnitudes of A and B, and the angle between them, then that's how you would get the dot product. But sometimes you just are given the components. You don't necessarily know the angle between them. And in that case, you use the components to find this dot product. So you take the product of the components of each vector. And so you just multiply these numbers together and then add them up. And that's how you get the number that is the dot product. Okay, and you'll be asked to do some examples of using those equations in your next assignment. Okay, now there's the cross product, which I also talked about in the last video. And you will be asked to calculate it. Okay, so this is the magnitude of the cross product between two vectors A and B. So what they're talking about is the cross product A cross B. This is the magnitude of that cross product. Magnitude of C. And remember, those are the two magnitudes. And once again, that is the angle between A and B. So if you know the angle between A and B, you can get the magnitude of the cross product. If you want to actually get the components of the vector, then you do the little determinant, where you go I hat, J hat, K hat, and I'm sure you've done this in your math class, so everyone should know how to do this. And you put the components of the first vector. Now it is very important the order in which you do this. So A cross B does not point in the same direction as B cross A. So it's important that if you're doing A cross B, you put A first, and then you put B in the second row. And then the answer is a vector. So remember, the way I do it is I put my finger, cover the first column. This is the I hat component. And then I do the little determinant. So I go across this way, across, so A, Y, B, Z minus A, Z, B, Y. And then you go and you cover the middle column, but you have to go plus. So it would be plus I minus J plus K minus L plus M and so on as you move along. So it's plus I, now it's minus J hat. And I cover this column and then I go cross cross. AX BZ minus AZ dx. And then the last component, K hat, so it's plus K hat. Cover the K column, and now I go the little determinant, AX BY minus AY BX. And that gives you the components of the cross product. Now, it will be important to know the direction, and this is the right-hand rule. And gosh, I don't know, I usually just show this with vectors up in class. So the way I do it, if I have two vectors, say A and B, that lie in a plane, and these guys are lying in a plane here, and that's A, and that's B. So the A and B vectors lie in a plane. The cross product is perpendicular to that plane. So it either points up or it points down here. And so what I do is I take A and I turn it toward B, and I pretend I have a screwdriver in my hand, and I go turn, and that would generate the screw that goes down this way. And so C would be down. Now you're going to have to look at videos on how to do this with your fingers for the cross product, but just beware, A and B don't have to be perpendicular to each other when you take your cross product. So A and B can be any old vectors. Those two vectors define a plane. C would be perpendicular to the plane. Okay, so that's it for the equations for chapter 1.